All right. So, Algebra 2. Today we were looking at how to calculate the speed at the end of the roller coaster. Just as a reminder, the formula that we are using for that is as follows. We use the fact that d is equal to v sub I multiplied by t plus 1 half a multiplied by t squared. And a couple things really you should be keeping constant. D, unless you have to change it, should be 50. A should be a negative 9.8 since gravity is going to be working against us. And then your initial velocity is however fast you are going at the end of your ride. And that can be a couple of different things. You saw in class today where our velocity at the end was very slow. I'm also going to show you what would happen if you were actually going at a decent speed at the end of your ride. One of the big things that I've been asked is, what about belts? Like, what if you have belts for your last interval? Kind of how would you calculate into the ride using belts? And it's a great question. Let's kind of talk about what would happen. First off, distance, you should still leave that as 50, at least initially. And again, that will probably change, but who knows. Now, remember with belts, you're traveling at a total of 1 meter per second. So if you look at the calculator, what I'm going to do is take that 1 meter per second, multiply by 0.4, which gets you that your initial velocity here is going to be 0.4, and that's going to be in front of t, plus your 1 half multiplied by negative 9.8 t squared. So then kind of moving some stuff around, 0 is equal to negative 50 plus 0.4 t minus 4.9 t squared. And then remember, I like to put stuff in standard form, so negative 4.9 t squared plus 0.4 t minus 50. At which point, again, I would recommend using quadratic formula on your calculator to solve that equation. If you don't have quadratic formula on your calculator, just do a quick Google search for quadratic formula program on like YouTube or anywhere like that. And it'll usually take you through step by step how to program that. If you need to, I can always also make a video of that as well. But for this one in particular, once I'm running my quadratic formula program, I've got negative 4.9, 0.4 for my b value, and I've got negative 50 for my c value. And really, is no surprise, you notice that the end of my answer is going to be a complex number, and so I'm not going to be able to stop in 50 meters. I mean, it's not going to take me 50 meters. I'm going to run at a speed well before that happens. So what I'm going to do then is I'm going to basically take this equation, put it into Desmos to try to change this value right here. Now keep in mind, while it's negative, this represents your distance that you need to be able to stop your ride. So while we're going to have to put in negative values, remember distance is going to be a positive number when we're done. So doing that, I'm going to go ahead and go to Desmos. Let's see. In fact, I'm going to open up a new window. Why not? So on Desmos, probably the easiest way to do that is once you click Start Graphing, to go up here towards where it says Untitled Graph, click Open Graph, and then click on Parabola Standard Form. Notice that there is another standard form. This standard form, it says plus tangent. Don't use that one. Just use the one that says regular standard form. At which point I'm going to change a couple of these. My a value I already know is going to be negative 4.9 no matter what. You can't change the force of gravity. Your b value is going to be that 0.4, which was your speed kind of at the end. And here's the thing about c. C has to be a negative number. Now with us at negative 50, that's already way down there. I mean, if you zoomed out far enough, you're going to see it eventually. It's all the way down here. It needs to be crossing your x-axis at some point in order for it to have a real solution. And so what I'm going to start to do is just kind of play around with the c value to try to get to work. Like if I type in negative 5, I still can't see it. I mean, if you zoom out, you can start to see it down here, but still not small enough. So negative 2, so a distance of 2 meters, still not going to be short enough. A distance of 1 meter, still not short enough. A distance of a half a meter, still not short enough. I'm just going to keep kind of dividing by 2 till I get close. 0.25, still not short enough. 125, 124, still not short enough. Let's see, 0.05, how about that? Ooh, now we're starting to get close. I need to go a little bit up higher, so let's make it a little bit smaller. In fact, really at 0 is pretty good. Let's try to get at least some numbers out of it. 0.02, nope, 0.01. We're getting closer. And this is really just kind of the trial and error part of it. And at 0.005, let's kind of use that as our distance. So we were able to get it to where with a time of 0.06622 seconds, we are able to stop in a distance of 0.005 meters. So remember, this C value that we've been playing around with, C represents your distance. And so our distance for this one, where we were finally able to get it to work, was at that 0.005 meters. Then the time, there's actually two times if you notice. There's this 0.06622 and this 0.01541. You can use either one, it does not matter, but I would probably use the one that's a little bit longer, so 0.066 is what I'm going to write there for my time in seconds. Here's 0.0, is it 0.066, got it. And so keep in mind that as you write this stuff down, you also need to be aware of the fact that you may have been using different spacing. So let's say you were counting by tens for your time, then you would need to go back and say that this is really 0.6 seconds. Or maybe for distance, you were counting by tens of meters, so this is really a distance of 0.05 meters. And so in other words, for belts, you're not going to need to slow down very quickly, and you're not going to need a lot of distance to do that. So this is kind of your scenario if you have belts and kind of the work that you'd have to go through for that. Some other possible scenarios, let's say your graph was going pretty quick. Like let's say you ended up going about, let's say you were going about 98 meters per second at the end of your ride. Now keep in mind, you're going to have to factor in friction. So that 98 meters per second, if we take 98 multiplied by 0.4, I'm going to come up with an answer of about 39.2. So 39.2, let's say that was our final speed of our roller coaster. This is with friction already taken into account, so this will be what we use for V sub I. Let's go back through those calculations and kind of see what we come up with. So we've got 50 is equal to, we've got our 39.2 multiplied by t. I'm going to go ahead and leave that as my simplified negative 4.9 t squared from before. And again, that's coming from 1/2 a multiplied by t squared. Let's move the 50 over. 0 equals negative 50 plus 39.2t minus 4.9 t squared. And then let's put this in standard form. So negative 4.9 t squared plus 39.2t minus 50. And let's kind of see where this gets us. So once again, once you've got this equation, before you even try Desmos, you need to first just see if it'll work, because maybe we'll get lucky this time and it'll be something that will actually work for us. So negative 4.9 for our A value still. Now we've got 39.2 meters per second as our final speed coming into the station. And we're going to leave that as a negative 50 for our C value. And for an answer, we actually get some answers. And notice that these are real answers. So as potential outcomes, we could either slow our ride down quickly and say 1.59 seconds would be our label there. So this would be your time. Or you could use 6.41 seconds. For me personally, I would probably slow it down with this. Just because, again, when you're looking at dependability, this is going to be a more dependable. It's going to cost more because it's going to cost you more to be able to build those extra tracks. But I would say 6.141 seconds is going to be more dependable, which is what I would go for. 1.59 is going to be cheaper, but it's going to be less reliable. And keep in mind, for any of you who are not using belts but are doing something similar, you would be doing pretty much the same thing as what we did to find our speed with belts, just for whatever you had as your initial velocity in place of t. So let's say instead of a b value of 0.4, let's say you had a little bit higher speed going in, like 3.2, to where now we've got to figure out kind of where we're crossing, and now we don't need it to be quite as steep, so our c value can maybe make 0.1 or 0.2 even. And then you're looking at a time of 0.54 seconds and a distance of 0.3 meters. So keep that in mind. That's really the only thing that would change if you ever had a speed that was something other than 1 meter per second, is you would just change your B value there. If you guys have any other questions, let me know. I'll be here before school on Wednesday as well as after school today on Tuesday, if you guys need any help. So, all right.